How's it going, everyone? In today's video, we'll be going over how to create a procedural animation system to give some extra punch to your first-person animations. To give an overview of how this system works, we'll be tracking the movement of our Viewmodel's dominant hand, saving its acceleration relative to the chest bone, and using this value to drive an offset of the first-person camera. This subtle effect is most noticeable on nearby objects and should not negatively impact the player's aim whatsoever. Before we start, I want to give a shout out to Bungie's 2015 GDC Session regarding first-person animation for helping me wrap my head around best practices for this animation system. Specifically around the 24-minute mark, where they start a deep dive into how they animate the first-person camera in Destiny. A link to the full session will be included in the description below, as well as the assets you'll need for today's episode. With all that out of the way, let's get started. In your first-person character BP, create a new function called proc-cam-anim. We'll start out by getting the socket transform of Mesh1P's spine 03 and hand R bones, splitting the latter's output pin. Get an inverse transform location node, using the right hand's location and the spine's entire transform as its inputs. Use the output in the bottom pin of a vector minus vector node, and promote the top pin to a new vector variable called prev-hand-lock. Split this node's output pin, and add a vector times vector node, splitting the top input pin. Convert the axes to those needed by the camera skeleton by using X for Z, Y for X, and Z for Y, and use the multiply node to invert both the X and Z values. Promote this output to a new vector variable called cam-offset, and set it using the function's execution line. Multiply the output of this set node by a new float variable called cam-strength, setting the default value to 50. After this, use the output of the inverse transform location again to set prev-hand-lock. Moving down a bit, we'll use Mesh1P's Anim instance to determine whether we're currently playing a montage. Use world delta seconds and a couple division nodes for framerate independent interpolation, then add a vinterp2 node using the output of the multiply by cam strength as the target value. Promote the current value to a new vector variable called cam-offset-current. Add an finterp2 node using our montage check as the target value, and promote the current value to a new float variable called cam-anim-alpha. Clamp the size of the output vector of the vinterp2 node between 0 and 10, and use this node to set cam-offset-current. Finally, use the output of the finterp2 node to set cam-anim-alpha, and add a return node that passes these values through the end of the function. Back in the event graph, add this new function to the end of our walking timeline so it's called every frame. In the content browser, find our camera skeleton and create a new animation blueprint assigned to it. In the event graph, we'll save a reference to our player character and use it to get and set local versions of cam-offset-current and cam-anim-alpha. Back in the content browser, open up SK Camera and use the Create Asset button to save a new base pose for the camera to use in the animation graph. Back to the animation graph now, use the base pose we just made and create a new transform bone node after it, setting the bone to modify to camera. Hide all of the input pins, then bind translation to cam offset with the mode set to add, and bind alpha to cam-anim-alpha. Connect the output to the output pose node, and we're now finished with the camera's animation blueprint. Back in the player blueprint, set CamScale's anim class to camera_AnimBP. Now we'll create an animation notify state to play animations on our held weapon in sync with montages played on our Viewmodel arms. Open the new ANS asset and override the function received_notify_begin. Then use the mesh comps owner to cast a first-person character. Use the cast to call getWeapon, then get the weapon mesh. Stop currently playing animations on the mesh, then add a play animation node. Create an animation sequence input variable called weapon_anim, making sure it's instance editable and exposed on spawn. Use this variable for the new anim to play pin, and now we can put this ANS to work. Drag and drop the weapon reload animation from the link in the description to an appropriate folder in your content browser, using skfpgun as a skeleton. Open the asset, tick on Enable Root Motion, and set the play rate to match the Viewmodel's reloading animation. In this case, it'll be 3.5. Then, in our FP reload montage, add the ANS to the notify track, and set the weapon_anim input to weapon_reload. Open up weapon_basic rifle and call our established reload event. This is purely for demonstrating the procedural camera animation for now, but we can go back later and flesh this out for proper functionality. We'll also use a boolean variable for now to prevent overlapping animations. In your project settings, add a new input called reload and set the key to R. Then navigate back to the player blueprint and add a call to the reload input. Finally, use getWeapon to call the reload event on the gun itself, and we're ready to see our progress in-game. Our camera motion at this point looks great, but we'll need to offset the Viewmodel arms by the same value or we'll see them move around in unintended ways. To fix this, open up the first-person AnimBP and get cam offset current from the player reference. The Viewmodel arms use a different forward axis than the camera, so we'll need to set X to Y, Y to X, and multiply the X value by -1. Promote the output to a vector variable called cam offset, and get cam anim alpha and promote it to a float variable of the same name. In the anim graph, add a new transform bone node and set the bone to modify to spine 3. Bind translation to cam offset, setting the mode to add to existing. Hide the pins for rotation and scale, and finally bind the alpha to cam anim alpha. Now when we try it out in editor, you'll see the Viewmodel is properly framed again while maintaining that nice camera movement. We can adjust the intensity of this effect by changing the value of cam strength in the player blueprint. I use 25 as a baseline, but feel free to change this to achieve the feeling you're after. However, I'd recommend not cranking the value too high or you may start to see undesired results. We can take the system a step further by interpolating the Viewmodel offset separately from the cameras so it lags behind a tiny bit. Back in the first-person AnimBP, use the same vinterp2 technique we used in our procam anim function. Promote the current value to a new vector variable called cam offset current, updating it with the execution line. Swap out the translation binding on the transform bone node for this new variable, and now we're ready to check it out in-game. Playing in the editor, you'll see that with no hard-coded camera shake assets, we're getting nice camera movements that make sense in the context of what your character's doing with their dominant hand. This system will accommodate any sort of unique Viewmodel animation you create for your game going forward, and later on we can parameterize the function's target bone if your character's performing an action with their offhand instead. If you have any questions or concerns, feel free to leave a comment below or consider joining my game's Discord server through the link in my channel bio. I hope this video helped you out in some way, and stay tuned for more content coming soon. Until next time.